Hi everyone. So welcome to my class. This is going to be lecture number 9. Okay. So after a long time we are conducting this session, right? So I think many of you might have covered your backlogs. Many of you might have finished signal and system as well. And till this point, I mean till this lecture number 9. Okay. So I request everybody to watch that session. I mean, all the session you have to watch it because I'm just going to get it started from this lecture only. So I have covered, the amplitude modulation, right? That was standard modulation. I think you guys can recall the mathematical equation as well as you can also talk about time domain representation, right? So in this session, what I'm supposed to talk about, I will talk about some of the important modulators, okay, like modulators, okay. We'll also discuss demodulation, okay, demodulator, but I start with the modulator like square law modulator and okay. So please do cover whatever I have covered till this point, understand, and make sure that signal and system must be very good, like the Fourier transform, okay. So let me minimize myself, yeah. So I'm just going to start with the modulator. Okay. So we will talk about square law modulator. Okay. Square law modulator. Okay. So what is this modulator, guys? Modulator is nothing but a device which is going to modulate the signal, right? And I think everybody is by now familiar with what is the meaning of modulation, right? And we are talking about amplitude modulation. The amplitude of the carrier is changing according to the massive signal. That is the reason we call it amplitude modulation. Okay. But in general, if you talk about Fourier transform of any signal, right, and if you multiply any time domain signal with cosine or exponential or sinusoidal, so your spectrum is going to get shifted. Remember this. Okay. So that is nothing but your signal is getting shifted from low frequency to high frequency. That is the very basic definition of modulation. Okay. So square law modulator will be having what kind of block diagram that you must know. Okay. So I think everybody have seen the modulator, right? So this is going to be your modulator. Okay. So sometimes in the gate examination, what they will do here is in the gate question, they will directly put this block diagram. Okay. So you have to follow each and every operations that block diagram offers. Okay. Please understand. So block diagram understanding is very important. Okay. So you have got this. First of all, what you have to do here is you have to multiply empty. Okay. You have to multiply empty. See, in case of standard modulation, let me tell you, in case of standard AM modulation, okay, amplitude modulation, you can say what we do always is we multiply the signal, okay, with the carrier as well as we add carrier. I think you might have seen that. Okay, we multiply the carrier. If you recall the standard equation of the AM modulation, or you can say modulated signal, so message is called as modulating signal, but once the modulation is done, that is known as modulated signal. Okay. So first of all, what you have to do here is you can take message signal, right? And you're going to, put the summer here. So this is going to be summer, and you will add your message signal with a carrier signal here, right? So this is going to be a carrier, and carrier is AC cosine 2 pi fct, right? And then it will produce some kind of output that is nothing but vi. So I'm talking about modulator, guys. Okay, modulator. Okay, so where does modulator exist? It will be toward transmitter side. So right now I'm not in the receiver side. Okay, I'm currently preparing my signal, okay, to be able to transmit, okay, via channel, understand? So before you transmit the signal, you have to make your signal ready, understand? So I have covered everything, ठीक है, and I have also computed some of the important parameters, ठीक है? तो अभी आपके पास MT दिया है, CT है, बस इनको आपको ऐड कर देना है, तो you will get VI, okay, you will get VI, which is nothing but a function of time only, VIT, okay. Then the next block is going to be a non-linear device, guys. So square law modulator will be having non-linear device, non-linear device. Okay, non-linear device. I think many of you might be familiar with non-linear device, right? Okay, non-linear device will be there. Okay. Example, you can say non-linear device in the sense that example you can say is nothing but diode, or three-terminal device is nothing but transistor, right? Diode as well as transistor, diode as well as transistor. Okay, so empty CT you add it and then give to the non-linear device. And non-linear device, we have got two-terminal device which is the diode, or three-terminal device which is nothing but a VGT or transistor, you can say, right? And then the output of this guy, output of this non-linear device, that is nothing but V out T. So input will be the sum of message signal as well as the carrier signal. Okay, then you have to pass it through non-linear device. Please remember, sometimes in the gate examination what they do is directly they will ask question. Okay, they will put the block diagram and they will ask question. Okay, and what kind of question they will ask, I will tell you, right? So empty CT, and that goes to non-linear device. Okay, non-linear device, so you will get some output here. Now they have given the relationship, okay, between output and input, okay, for this non-linear device, like how this input and output is described by this non-linear device. That is given as V out is equal to, V out is a function of time only, right? So let me write here. So this is the equation that also you have to keep in mind. Okay, so V out T is going to be equal to, okay, K1 is nothing but a constant, VIT plus K2 VI square. Okay, okay, K2 VI square. So here square term talks about, yes, this is a non-linear device. Okay, understand? So if there is no square term, means that can be linear. Okay, but it is a non-linear device. Okay, because the input is being squared here. Okay, so this is the description that you have to remember for NLD. Okay, we call it NLD. Okay, NLD, understand? Now what you have to do here is, after getting this V out, okay, T, you have to pass it through ideal band pass filter, as I told you also. In the receiver side, okay, in the receiver side, what you have to use, guys? In the receiver side, you have to use ideal band pass filter. In the transmit, not receiver side, please correct it. Okay, in the transmitter side, you have to use ideal band pass filter. In the receiver side, you have to use low pass filter. The reason is, if you're modulating your signal, right, so your signal is going to get translated at high frequency. Okay, if your signal is getting translated at high frequency, so that is the advantage, right? Okay, because you will be having the dimension of the antenna very less. You will be able to physically realize the antenna height. Okay, and there are other many reasons, right? So remember this, you have to use in the transmitter side, okay, the ideal band pass filter, and in the receiver side low pass filter, because you have to get back your signal, right? And your signal will be having a very, you can say, less frequency signal. Okay, low frequency signal, understand? Low frequency signal. Okay, so I think this is clear for all. Yeah, next is ideal low pass filter. So let me put here ideal low pass filter. I think you will not be able to see me or somewhere down the line. Yeah, so I can put like this: ideal band pass filter. Okay, in the transmitter side, and that will give you the modulated AM signal, ST, which is AM signal. I think you understood entire block diagram. Okay, entire block diagram of what? Entire block diagram of this square law modulator. Okay, okay, understood. So this is one of the important facts. Remember this. Okay, And you know that ideal band pass filter, how does it look like? Okay, the pass band should be unity. Okay, and the pass band should be from minus f, you can say fc minus fm to fc plus fm. Okay. So what we can do here is we can follow whatever operation we have to perform here. So you can write what is this vi. So you can say that this vit is going to be your message signal plus your carrier signal, which is AC cosine 2 pi fct. I think anybody can do this. Yeah, ये तो आप कर सकते हो. You can find vi because you are just adding. This is a summer. Okay, summer. Before you pass it through a non-linear device, okay, you have to first add message signal as well as the carrier signal. आपको ये याद रखना है कि आपको कैरियर भी भेजना पड़ता है, एंड दिस इज नॉट द एडवांटेज हियर. ओके, आई विल टॉक अबाउट द डिसएडवांटेज. As I said that there are two important parameters that we always talk about as an communication engineer. The first is nothing but communication. In communication system we talk about bandwidth as well as the power. So here the need of modulation, the amplitude modulation, in case of standard amplitude modulation, you have to transmit extra carrier as well. Okay, so carrier plus message signal. Okay, this is important. So you have to first add one carrier mt plus ct and then pass it through non-linear device. Okay, so we can pass it through non-linear device now. ठीक है, आप लोग पास कर सकते हो, ये मैथ्स है और कुछ भी नहीं है. ठीक है, मैथमेटिक्स इज देयर. So what we can do here is we know that vit is going to be message signal plus AC cosine 2 pi fct. Okay, then what is output, guys? Output is going to be k1 times vit plus k2 times vi square t, right? Kind of square law. Okay, or non-linear device. Then you can put these like you can put this guy right in place of so here you can say k1 mt plus k1 mt plus k1 AC cosine 2 pi fct plus k2 times, you can take the square of this, right? So this will give you m square t plus AC square cosine square 2 pi fct plus 2ab 2mt AC cosine 2 pi fct. I think this is okay, right? This mathematics is okay or not? I'm just putting the vi into this you can say the relation between output and input of non-linear device. ठीक है, make sure that the band pass filter will only pass the band pass frequency. It is going to reject low frequency and very high frequencies, right? Only it will pass what the band pass. Okay, and the band pass will be from fc minus fm to fc plus fm, centered around fc only. ठीक है, so I think this math you can do. Okay, because I'm not doing anything naturally, guys. Like I'm not doing anything artificially, please remember. I'm doing everything naturally, you can say, because I'm just looking at the block diagram और उसको follow कर रहे हैं जो भी block diagram की demand है. Okay, so I think this is clear, right? So what you can do here is you can take k2 inside also, so k1 empty. So these k1 empty and all will be eliminated, right? Okay, k1 AC cosine 2 pi fct, this will not be eliminated because this will be passing through ideal low pass filter. K2 m square t will also be then k2 AC square. Okay, cosine square cosine square 2 pi ct का मतलब क्या होता है? That is nothing but 1 plus cosine 4 pi fct, right? ठीक है, so that you can say that this is nothing but AC square by 2 plus k2, right? This is k2. Okay, k2 AC square by 2, then k2 AC square cosine 4 pi fct, okay, by 2, and then this will be as it is, right? So 2k2 mt 2k2 mt AC cosine 2 pi fct. So here I'm using some sort of trigonometric results. Okay, understand? Please remember this. I think everybody knows that also. Okay. So cos square theta, right? Cos square theta can be written as 1 plus cos 2 theta by 2. Okay. 1 plus cos 2 theta by 2. Okay. I think this is clear. Yeah. And this you can pass it through ideal band pass filter, right? Okay. So what are these signal that you will get? That is a question. Okay, so if you try to plot the spectrum here, if you try to plot, see. So if you plot it, so you're out, you can say that SMT is going to be equal to, this will not be passing through. You can say this will be not passing through. This is low frequency signal, and this is also low frequency. This will pass and this will pass. In fact, this will also not pass because it is not centering around FC. Okay, this is 2 FC. ठीक है, कुछ भी पास नहीं होने वाला है. पास क्या हो जाएगा सर? K1 AC cosine 2 pi FCT plus 2K2 AC cosine MT times. Okay, remember this. MT times AC cosine 2 pi FCT, right? So you can write this as, you can take common here, so you can take AC common, so which is nothing but okay, which is nothing but, you can also take K1 AC common, no problem, right? K1 AC common, so it is nothing but 1 plus you can say 2K2 by K1, right? MT cosine 2 pi FCT, right? Now you can compare, understand, this is the important result. Okay, in case of square law modulator, where we are using square, you can say square, understand? Okay, स्क्वायर लॉ डिवाइस, दैट इज नॉन लीनियर डिवाइस. ठीक है, तो ये आई थिंक समझ में आ गया होगा. इसको हम लोग पास करेंगे बैंड पास फिल्टर से. हमारा बैंड पास फिल्टर कुछ ऐसा दिखता है. दिस इज बैंड पास फिल्टर, यू कैन सी आइडियल बैंड पास FC minus FM, FC plus FM, right? And this is 1. ठीक है, so you will get this, and this looks like a standard AM, right? So I think you understood what is this square law modulator, right? So square law modulator means you have got the empty, then summer is there, add it, okay, pass it through nonlinear device, pass it through ठीक है, और आपको आंसर मिलेगा. तो एक क्वेश्चन भी आया था, वी विल टेक दैट क्वेश्चन डायरेक्टली, वी कैन सॉल्व. ओके, रिमेंबर दैट. ठीक है, and if you want to draw the spectrum, right, so you can draw it, no problem is there. Okay, you can draw it. ठीक है, so this is one of the important fact that you have to remember. Okay, so suppose empty, let me take one empty here, right? So empty we need to take, suppose we have got MF means the massive signal spectrum. We are considering this kind of a massive signal spectrum, that is, you know, from FM to minus FM. Okay, this is a massive signal spectrum. Okay, the low frequency spectrum, you can say, or baseband signal. Okay, baseband signal. So what you can do here is this is nothing but your Fourier transform of MT. Okay, this is what you can say, that MT is nothing but the CT of T of, okay, this is small mt, right? Time domain, if you take the Fourier transform, you will get the frequency domain, and this is band limited. Okay, everything we have discussed. Suppose you want to find out you know, the Fourier transform of M square. Okay, because in the process you might have seen there is a m square kind of thing. What is this m square? What is the Fourier transform of m square? Right, so m square is nothing but what, guys? M square is nothing but mt into mt, and we know that multiplication in time domain, okay, multiplication in time domain correspond to convolution in frequency domain, right? So if you convolve this, right, so the lower limit and the upper limit you can find out, that is nothing but minus fm to minus m, that is to minus 2fm to 2fm. Okay, understand? So you will get this kind of a situation. Suppose this is nothing but your by t, so your by f is going to be looking like this, कुछ ऐसा आएगा, ठीक है, जब आप कन्वोल्यूशन करेंगे ना, दिस काइंड ऑफ सिचुएशन, and this will be at minus 2fm and this is at 2fm. This kind of a spectrum will get. So it will, your spectrum will be from minus 2fm to 2fm, that's it. Okay, minus 2fm to 2fm. Okay, when you will convolve, okay, this is nothing but what, convolution, you know, minus fm to fm convolve with minus fm to fm. Okay, so convolution is gonna be looking like this. Okay, this is the lower and this is the upper. Okay, how to find that? You add this and this, this and this. I think those who attended my class on convolution, they can do this, right? So this is the spectrum for m square t, the message signal when it is squared, right? Okay, I think this is clear. So this ideal band pass filter will be having, you can say, the center frequency, right? We call it center frequency, which is nothing but fc, and the bandwidth is going to be what? The bandwidth of this 2 times fm. You have to maintain this much bandwidth, okay, so that your modulated signal can get transmitted, because the thing is can pass through this band pass. Okay, why we are introducing band pass filter before it gets transmitted? We don't want to send low pass signals, right? We only want to send the signal of interest, right? The high frequency signal. Understand? I think this is clear. Yeah. So ये आपको याद रखना है हमेशा, ठीक है, जो मैंने अभी बताया. ओके, सो अगर आप स्पेक्ट्रम ड्रॉ करेंगे तो स्पेक्ट्रम ड्रॉ कर सकते हैं. फाइन, लेट मी ड्रॉ द स्पेक्ट्रम आल्सो. इसका स्पेक्ट्रम हम ड्रॉ करेंगे, इसका वी आउट टी. Directly I will draw. I will not find that Fourier transform. Okay, spectrum of V out T, which is in time domain. So you can say that it looks like this. See, something is at low frequency, that is nothing but, okay, massive signal K1 MT, right? That is from FM to minus FM. And there is also, you know, K2 MF square. So it will be nothing from, you can say here, this is nothing but what? The height is going to be K1. ये आपका K2 है, and this will be from here minus 2 FM to plus 2 FM. Okay, the spread is going to be like this. Understand? The height is going to be what? K2 AC square by 2. K2 AC square by 2. There will be one impulse as well. Okay, this is the impulse at f equal to 0. Understand? So here I think this is clear for all. Yeah, so आपको देखना है कि मैंने ये ड्रॉ किया सबसे पहले इसका Fourier transform. Then you can also draw the Fourier transform of this. So you will get two one impulse at fc, one impulse at minus fc. Okay, this okay, we have drawn this. Okay, what is the Fourier transform of this? We have drawn it. Okay, this is the Fourier transform of this. Okay, that impulse constant का होता है Fourier transform impulse, right? That is AC K2 AC square, that. Okay, next What is this, guys? Can you tell me what is the Fourier transform of what? Fourier transform of this? Fourier transform of this. What is Fourier transform of this? That is important. The Fourier transform of this is going to be massive signal times the carrier, means fc plus fm, fc minus fm. So I'm just going to draw that also, right? Okay, so I can say that this is nothing but your fc. Okay, this is fc, very high frequency, and there will be one carrier as well. Carrier having the same height, that is AC k1 by 2. Okay, AC k1 by 2, and then this is nothing but your modulated signal, right? Which is nothing but fc minus fm, fc plus fm. Okay, so I'm plotting everything on single. Okay, I'm plotting the spectrum of V out T without passing it through you can say band pass filter, right? So that you can find out one of the very important concept I am just going to tell you. Okay, so I think this is clear, and this will be K2 AC, K2 AC. Okay, and you're going to also get your impulse at this point, that is nothing but 2fc, and the height is going to be K2 AC square by 4. Okay. I think this is clear, yeah? So this is the scenario, K2 AC square by 4, okay? And in this case, K2 AC square by 4 will be the Fourier transform and impulse. Okay. So this is the impulse that I have drawn, okay? And it will be also having the negative counterpart that I'm not drawing, okay? Please remember that, ठीक है? मैं उसको plot ही नहीं कर रहा हूँ negative side को, only we are drawing, positive. So what I just want to highlight here is यहाँ से क्या question बन सकता है? इससे एक question बन सकता है आपका, ठीक है? I think you are not able to see this. इससे एक question क्या बन सकता है? इससे बन सकता है कि sir, for proper operation you can say, for proper operation, for proper operation, okay, what will be the minimum carrier frequency? Okay, what will be the, for proper operation, what will be the minimum fc, right? So कैसे find करेंगे? That you have to notice here is that there should be a gap. There is a difference, right? You can see this is 2 fm and this is fc minus fm, right? Okay, understand? So this difference must be greater than or equal to 0. Okay, this difference must be greater than or equal to 0. So what you can do here is you can say that this difference must be greater than or equal to 0, right? So for proper operations, so that difference must be greater than or equal to 0. That is nothing but, what is the difference here, guys? fc minus fm minus 2 fm, fc minus fm minus 2 fm, that must be greater than or equal to 0. So here fc minus 3 fm, which is greater than or equal to 0. So here fc must be approximately equal to 3 fm, which is minimum. So I think everybody can find out fc like this, yeah, by drawing the spectrum. Okay, so how I have drawn the spectrum you should know, right? ठीक है, स्पेक्ट्रम कैसे ड्रॉ करते हैं ये आपको मिलेगा जब आप चैप्टर पढ़ लोगे तो, ठीक है? तो ये पॉइंट आपको याद रखना है फ्रॉम द एग्जाम पॉइंट ऑफ व्यू, important for gate. From here you can expect some question, right? बहुत सारे लोगों को समझ में नहीं आता है, बट आपको समझ में आ रहा होगा, ठीक है? कि this gap is very important, should be always greater than 0. They should not mix here, okay? And you will be able to realize it when you will draw the spectrum of the output, of the, you can say, nonlinear device. Okay, spectrum of the nonlinear device. Now what you can do here is you can pass this guy through ideal band pass filter, and you will get the standard AM, right? Now the question is, what is the demodulator, right? So this is one of the very important popular modulator that I wanted to discuss, which is important for your exam. But now I will talk about demodulator as well. So I think modulation में आपको समझ में आ गया क्या करना है. देखो, जब भी आपको modulator यूज करना है, ओके, modulator में क्या क्या होता है. If you want to get you can say this is nothing but a generation technique as well, generation method of AM signal, right? Generation technique. Okay, how to generate standard AM. Sorry, how to generate standard AM, I must write. ठीक है, तो उसके लिए स्टेप क्या क्या है. सबसे पहला क्या करोगे, MT and CT. What you will do, you will add it. You will get here MT plus CT. Then you have to pass it through what, NLD. Okay, then NLD will be described by, suppose you can say this is input, this is output. So your output is gonna describe by A times Vi plus B times Vi square. You can simplify the constants, and then you have to pass it through IBPF, and this will give you SAMT. ये live है. So you must know that how to draw the spectrum of this guy output, okay, before you pass it through ideal pass filter. तो I think spectrum draw करना ज़्यादा difficult नहीं है, ठीक है. And those who do not know how to draw the spectrum, then they must revise all the 7 to 8 lectures, whatever I have taught. How by inspection you can draw the spectrum, you should know, okay, if you are good at Fourier transform. ठीक है, तो आपको बाई इंस्पेक्शन स्पेक्ट्रम ड्रॉ करना है. ठीक है, क्वेश्चन बहुत सिंपल आएंगे, वी विल डू सम प्रीवियस ईयर, तो यू विल अंडरस्टैंड. ठीक है, ये हमारा मॉडुलेशन है, मॉडुलेटर job है, right? Job of the modulator, you can say. Now we will talk about, guys, demodulation. Demodulator, okay, or kind of demodulation, you can say, right? So these are the devices that we are discussing, demodulators. So there is also a square law demodulator. Okay, the very first is square law demodulator. Okay, so if you have modulator, so you should also have the demodulator, okay, because at the end of the day you have to get back your you have to get your signal back, you have to get your information back, because somebody is sending the message signal, okay. So in the receiver side, that message signal should get also received now. If you're not receiving the message signal, then there is no use, understand. सो आपको एक एक पॉइंट याद रखना है जो जो मैं बोल रहा हूँ, राइट, जैसे मैं बता रहा हूँ बस आप उसको पढ़ते जाओ. सो या, सो नाउ द क्वेश्चन इज व्हाट गाइस, व्हेन योर सिग्नल इज गोइंग टू बी passing through channel, and we are now in the receiver side. So when the signal is going through, propagating through channel, okay, after modulation, after transmitting the signal, आप जो सिग्नल रिसीव करोगे ना, दैट विल नॉट बी ओनली द सिग्नल गाइस, देयर विल बी व्हाट, दैट विल नॉट बी ओनली द सिग्नल, दैट इज गोइंग टू बी, there will be noise added with the signal. This is important fact, okay. So when we talk about square law demodulator means we are going to get back the low frequency signal again, right? But what is the process here, what you are going to receive at the receiver? So receiving signal is going to be what? Receiving signal is going to be RT, which is a signal ST, that is the modulated signal, plus the noise, and this noise is going to get added by the channel. Noise added by channel, ये receiver side होता है, ठीक है. Initially there will not be any noise, but once you are sending that, okay, so there will be a noise, okay, certainly, ठीक है. Signal plus noise, okay. So initially we have to assume that, okay, for the sake of convenience, we will make assumption that the noise is zero here. Okay, we will make assumption, okay, the noise is zero, okay, so that we can analyze better, understand. So what we can do here is, let us recall the block diagram of this. So let me use some different color. So here it will be non-linear device, we call it NLD. You can say N is going to be 2, okay, that is nothing but like square, okay, square law we call it, na, that is why N equal to 2 here. And let us assume that this is my assumption that the noise is zero. Whatever receives signal you are receiving, that is nothing but original AM signal. AM signal is nothing but what? The message signal and the carrier signal multiply हो जाता है, फिर plus carrier also, okay. इसीलिए हमारा AM सिग्नल जो होता है ना, उसका पावर बहुत ही ज़्यादा वेस्ट जाता है, because you are sending carrier, right? So you're going to waste your power a lot, okay, in this process. So just my assumption is the noise is zero at this moment, but practically it is not correct, okay. Just considering ideally that, you know, noise is zero, okay, and we are passing through non-linear device, and this is nothing but your output T, okay, output T. Then can you tell me what kind of filter I'm just going to use here? What kind of filter I will use? I will use here the low pass filter, and that too, that should be ideal low pass filter. Ideal low pass filter. I think everybody can witness what is the meaning of ideal low pass filter. Yes. Ideal low pass filter. Okay. And the cutoff frequency must be, what should be the cutoff frequency of ideal low pass filter? That should be FM. Okay. There was FC here, cutoff frequency is FM, because the message signal having the bandwidth FM only, okay. And you will get what? Your message signal back, MT. Okay, this is the demodulator, okay. But this message signal will not be, you can say, actual signal. It will be nothing but a distorted one. Okay, distorted signal you will get, okay. Understand? So this is important, right? From where this distortion come, you know, right? Okay, that will come from the filter also. Okay, the filter here I'm using ideal low pass filter, but what do you think? We can always have the ideal low pass filter. Can we design? Can we realize? No. We are just talking, you know, with respect to convenience one, like ideal low pass filter. Because some part of, you can say, M square T components also coming at the output of the filter, right? Okay. M square T will be out. So let us, you know, let us recall what is ST, right? Standard ST that you should know. ठीक है, तो ये आपको याद रखना है. This is nothing but your standard or you can say square law demodulator. Okay, so क्या क्या यहाँ पर है? NLD है. Already you have got this carrier, so you don't have to add carrier here. Already carrier is there, and NLD and low pass filter. बस दो ही blocks हैं यहाँ, ठीक है. So we can recall ST. What is ST, guys? In case of AM, ST is nothing but let me recall, that is AC cosine 2 pi FCT plus KMT cosine 2 pi FCT. I think this anybody can recall. Okay, this is the standard AM, right? This is the standard AM. Okay, and this is equal to, you can say, your input only, VI, input to the non-linear device. Okay. Now what is the output of non-linear device? That is nothing but K1 times k1 times vi plus, don't put square here, k2 times vi square t. Okay, sometimes in some of the book you will find a b, right? But here I'm using k1 and k2. These constants can be anything, right? So st equal to ac cosine 2 pi ct plus k mt cosine. ये तो स्टैंडर्ड है, ये याद होना चाहिए, ये मत सोचना कि धीरज सर अपने से लिख रहे हैं, ठीक है। अब आप यहाँ ये सब प्लग कर दीजिए, so k1 vi, right, that is nothing but ac cosine 2 pi ct. It will not be passing through an ideal low pass filter, plus k1 ka mt, ये भी पास नहीं होगा, ये सब रिजेक्ट हो जाएंगे, ओके, दे विल नॉट पास, ओके, एंड दे आर नॉट माय मैसेज सिग्नल आल्सो, ठीक है। mt times ct is a modulated signal, okay, but what I want is the modulating signal, or you can say information bearing signal, where the information is there, and we want our message signal which is centered around low frequency. So message signal has different names, ठीक है, आप लोग जानते भी होंगे कि message signal have low frequency, message signal, information bearing, base band, okay, so many names are there, ठीक है। बट ये सब हट जाएगा, इनको लिखने की जरूरत भी नहीं है, बट ठीक है, फॉर द सेक ऑफ कंप्लीटनेस प्लीज कीप राइटिंग वॉट एवर ब्लॉक डायग्राम सेज, यू कीप फॉलोइंग दैट, ठीक है। आई होप दिस मेक सेंस। नाउ you have to put inside this also, so this will be nothing but a plus b whole square, because this will be a square, this is b square, okay, and I think you understand, okay. So what we can do here is we can write that ac square cosine 2 pi fct, okay, square only, then here we have to also multiply k2, k2 ka square m square t, okay, okay, cosine 2 pi fct square only, okay, plus 2 times k2 ac ka mt, and this will be cosine square 2 pi fct, okay. So 2 times a into b, that's it, okay. So let me write the formula as well so that you can remember. तो ये हमारा क्या है, this is a square, this is b square, and this is 2ab, okay. Formula you know na, a plus b whole square is equal to a square plus b square plus 2ab, ठीक है। सो ये मैथ्स है, इसमें कुछ भी नहीं है, राइट, ओके, आई थिंक यू कैन अंडरस्टैंड दैट, इट इज नॉट, इट इज ऑल अबाउट very simple thing, okay. So I think this is clear, okay. So what we can do here is you have to identify the noise component, you have to identify the signal component, okay, that's it, ठीक है। So what do you think, let me, can we, will it be passing through low pass filter? No, so you can cancel it, ये नहीं पास होगा, okay. Now you can think about this and this and this, right? So यहाँ से कुछ कंपोनेंट्स आ रहे हैं, जैसे इसको अगर आप एक्सपैंड करते हो, लेट मी एनालाइज दीज टर्म्स, यू कैन से फर्स्ट टर्म, सेकंड टर्म एंड थर्ड टर्म, इन तीनों टर्म्स को हम लोग देखते हैं, ओके, एंड लेट अस सी व्हाट वी आर गोइंग टू गेट, ठीक है, ओके। सो लेट मी सी हियर, so whatever is going to get rejected, okay, I have cancelled already. So what is this, guys? This is nothing but k2 ac square by 2, okay, plus what, cosine 4 pi fct by 2, right? So let me write that k2 square by 2 plus AC square cosine 4 pi fct by 2. So ये तो आपका you know you can say yeah, just you get lost, okay, it will not be passing through, okay. And plus next is in this case you think about it, so again here also you will find kc k2 ka square m square t by 2 plus k2 k square m square t cosine cosine 4 pi fct. ठीक है, देखो so do you think this part is going to be passing through this part will be rejected also because this is 4 pi fct, this is 4 pi fct. तो ये जो है आपका ये this is important, okay, this is the noise component, ये हमारा noise component रहेगा, okay, and this is nothing but a DC guys, okay, I mean k2 AC square by 2, it is not a massive signal basically, so we can pass it through some sort of a some sort of capacitor, so these guys will get eliminated as well, okay. ठीक है, so हमें फोकस कहाँ करना है noise component में, and we have to focus on what we have to focus on. So here what are the component? I think we missed AC square, right? In this we haven't written AC square, yeah, we need to write AC square as well. So let me check out that ST. Yes, in fact I missed it, okay, so there should be AC as well, please write AC here. यहाँ पर AC होना चाहिए, तो यहाँ भी AC square हो जाएगा, and this is AC square, please correct it, okay. मतलब ST में आपको AC cosine 2 pi fct plus AC k mt cosine 2 pi fct, okay. तो ये सब आप याद रखना, मतलब याद क्या रखना है, यू शुड नो द मैथ्स, यू कांट रिमेंबर दीज थिंग्स, ठीक है, ब्लॉक डायग्राम बस पता होना चाहिए, रिजल्ट लास्ट में. सो द रिजल्ट आई विल टेल यू नाउ, ठीक है. सो देयर शुड बी AC स्क्वायर एंड देयर शुड बी AC स्क्वायर. सो ये तो पास नहीं हो सकता, ये भी रिजेक्ट हो जाएगा, it will also get rejected. This is nothing but your noise component, okay, you can say this is a noise. It is not a massive signal because your massive signal is getting square here, okay, because of you can say so there is some noise present. What is massive signal basically, that we have to see, okay. So what is the massive signal? The next component is going to give you, right, so this will give you massive signal here, right. So you can say that you will get k2 AC square k mt because 2 is already present, k2 AC square ka mt, okay, plus k2 AC square k mt cosine 4 pi fct, right. So again you can reject this guy, ये नहीं पास होगा. So this is your masses component, okay, you can say signal component. ठीक है, तो सिग्नल कंपोनेंट एंड नॉइज कंपोनेंट, ओके, वी आर जस्ट वरीड अबाउट सिग्नल कंपोनेंट नॉइज कंपोनेंट बिकॉज दैट इज ओनली गोइंग टू गेट पास इट थ्रू लो पास फिल्टर and nothing is going to pass through because all terms are having high frequency, ठीक है. और लो आइडियल लो पास फिल्टर का जो you can say the cutoff frequency है that is FM, ठीक है. I think this is clear, yeah. You can draw the spectrum, okay. I think plotting spectrum is not difficult, so let me draw the spectrum as well quickly. ठीक है, And what we have to exactly find out from this square law demodulator is we have to find out the signal to noise ratio of the device. क्या signal to noise ratio of the device? Wait, remember, signal to noise ratio of the device. This modulator, okay? So you will get some sort of, so in the exam they might ask you the question, ठीक है? आपको यहाँ से question क्या बनेगा? The square law demodulator is given and what is the, okay? So आपको मैथमेटिक्स है इसमें और कुछ भी नहीं है. In fact, I also find it boring, but unfortunately we have to do it, okay? So you will not find it boring because I have explained everything, ठीक है? So each and every term which has been passed through लो पास फिल्टर आप वो ड्रॉ कर सकते हो या कि आप पूरा स्पेक्ट्रम ड्रॉ कर सकते हैं, ठीक है ना? तो स्पेक्ट्रम ड्रॉ करना इज नॉट डिफिकल्ट टास्क. आपको करना क्या है, जस्ट ड्रॉ लाइन and there is fm, this is minus fm to fm, and there will be one okay, and there is going to be one more, you can say minus 2 fm to 2 fm. What is this? This is going to be your m square, okay? एंड आपको पता है कि ये जो डिस्टेंस है ना, ये थोड़ा सा 3 fm के अराउंड होनी चाहिए, ठीक है? दिस इज एफ सी, सो ये हो जाएगा एफ सी माइनस एफ सी प्लस fm, ओके? आई थिंक दिस इज क्लियर. एंड AC K1 K by 2, AC K1 K by 2, and this is AC K1 by 2. So these are the, you know, okay, this is DC here. I mean, it is present at high frequency, to it will not be passing through. Remember, AC K1, देखो ये फ्रीक्वेंसी जो है हाई फ्रीक्वेंसी कैरियर का पार्ट है, राइट? सो AC K1 by 2 जब आप प्लॉट करोगे ना, देन यू विल गेट टू सी, है ना? तो उसके अकॉर्डिंग आप पास करोगे तो आपको समझ में आ जाएगा ओनली मैसेज सिग्नल इज गोइंग टू बी पासिंग थ्रू, ओके, विच इज सेंटर्ड अराउंड FM एंड माइनस FM. तो इसको आप DC नहीं बोल सकते हो क्योंकि ये तो कैरियर कैरियर फ्रिक्वेंसी का कंपोनेंट है. AC, ओके, AC K1 by 2, ठीक है? मैंने क्या बता दिया था वहां पर कि DC है, नहीं, DC उसी मत बोलो, ठीक है? जब आप स्पेक्ट्रम ड्रॉ करोगे तो आपको समझ में आएगा. फाइन. सो अंडरस्टैंड, ये सब रिजेक्ट होने वाले हैं और एक आपका कंपोनेंट यहां पर भी रहेगा 2FC में, ओके? ये M स्क्वायर वाला पार्ट रहेगा, ठीक है? So this is nothing but 2FC minus 2FM, 2FC plus 2FM, and this is 2FC minus FM, 2FC plus FM, ठीक है? And this is going to be your K2 AC square by 4, ठीक है? I can hide myself so that you guys can watch it, yeah? So आप देखो यहाँ पर कि ये it is at 2FC, okay, it is at FC, so ये पास ही नहीं होगा. पास क्या होगा? ये वाला पार्ट बस, ठीक है? पास, that too noise है और क्या है आपका मैसेज सिग्नल. वी वांट जस्ट मैसेज सिग्नल, राइट? but device के वजह से there will be some noise as well, right? That, okay, this is the noise because of the device, okay, because already we are not considering the noise coming from the channel, okay? This is the noise because of the device, so we can find out the channel to noise, sorry, signal to noise ratio here, ठीक है? तो let me calculate the signal, important, okay, for the gate exam. तो आपको करना क्या है देन, okay, so what you can do here is you can take the signal part and the noise part component for the device. Okay, so I think this is the component here. You can take this and this, right? And then take the ratio of that k2 ac square kmt, and then here it is k2 ac square k square something, you know. So you will get here as, if you take the ratios, you will get 2 by, okay, 2 by kmt. This is the formula you have to remember, ठीक है, in case of square law demodulator. ये formula आप याद रखना. So you know that kmt is nothing but what, 2 times of mu. So your SNR depends upon mu also, ठीक है, your SNR depends upon mu, ठीक है. So if the mu is, this kind of question they might ask, if mu is lying between, you can say 0 and 1, between 0 to 1, so your SNR will be greater than 1, right? I mean it will be greater than 2, not 1, greater than 2, ठीक है. And if mu is equal to 1, SNR is going to be equal to 2. And if the mu is like under modulation is there, or over modulation, you can, this is the under modulation, right? And if mu is over modulation, you can say greater than 1. Okay. So your SNR is going to get affected. Your SNR is going to be less than 2. ये important है. This, from here you can expect question. Please remember this, okay? ये formula याद रखो. And ये formula related किससे है? Square law demodulator of AM standard AM signal, right? So I'm not talking about right now any suppressed class. I'm just talking about standard AM only, right? ठीक है. So आपको थोड़ा सा इसमें बोरिंग लगेगा, बट यू हैव टू ड्रॉ एवरीथिंग, सब कुछ ईमानदारी से करना, ठीक है. बाकी in the next class I will start synchronous detector, okay, that is also kind of demodulator only. It is important, synchronous detector, okay, ये हम डिस्कस करेंगे. उसके बाद हम डिस्कस synchronous detector is very easy, okay, the block diagram is very simple. And then we will talk about envelope detector, okay. So envelope detector से भी क्वेश्चन आ जाते हैं. Envelope detector, we call it peak detector as well, ठीक है. In analog circuit I think many of you might have gone through peak detector, ठीक है. And then I think this will be okay. So this will be the last, okay. So then you have to solve many questions, okay. Many questions are there. We will take up some question as well. लेकिन मैं सबसे पहले concept discuss करना चाहता हूँ. तो यही सारी चीजें हैं. उसके बाद we will start the suppressed class. Suppressed class, okay. So what we are going to suppress here is we will suppress band, suppressed band, suppressed carrier, okay. Suppress class में रहेगा. We will suppress one of the band, suppress carrier as well. मैं बताऊंगा क्यों suppress कर रहे हैं, क्या फायदा मिलेगा, ठीक है, all those things. सो स्टैंडर्ड एएम से आपको बहुत सारे क्वेश्चन मिल जाएंगे सर. स्टैंडर्ड एएम आप अच्छे से फॉलो करो. स्टैंडर्ड एएम के लिए जो इंपॉर्टेंट टेक्निक्स है मॉड्यूलेशन की, जो मैंने अभी बताया, मॉड्यूलेटर, स्क्वायर लॉ मॉड्यूलेटर, और डीमॉड्यूलेटर में आपके पास स्क्वायर लॉ है, एंड देन यू हैव गॉट सिंक्रोनस डिटेक्टर एंड एनवेलप डिटेक्टर, ओके. तो स्क्वायर लॉ से आपको क्वेश्चन आ सकता है डीमॉड्यूलेटर से, सिग्नल टू नॉइज रेशियो वाला, डिपेंडिंग अपॉन द म्यू, राइट. सो आपको देखना है. बाकी सप्रेस क्लास आई विल एक्सप्लेन. So we'll meet in the next session, guys. Keep learning. Thank you.